Hi, we're going to look at vertex form. Vertex form is another way of writing a quadratic, just to make it look a little different. Um, we are going to use a combination of completing the square, factoring, and then quick movements and transformations to help find the vertex of vertex form. So, in order to do that, I'm going to start with taking my problem. And I want to jump into this completing the square part. So what I do is I'm just kind of separating this -5, and then I'm only going to focus right in there. So in order to complete the square, we need that formula, uh, b divided by 2, and then square it. And in this case, we have 6 divided by 2, which gives us 3. Square that, you get 9. So we're going to put a 9 in there. Now, when you complete the square, we need to remember, if I'm adding 9 into a problem, I can't just add 9 and call it a day. I got to add 9 to one side, and then I have to add 9 to the other because I want to balance this equation out. So if I've got a y over here, I also want to put a 9 over there. Now, I know that's not probably mathematically correct looking, but that's okay because I'm going to move that 9. I want this problem to say y equals. So right away, I'm going to move this 9 back to the other side over here. So now, if I take this problem and I spread that -5 out, that's over here, I added 9, and then I took 9 away. So these two things end up canceling out with each other in the end. So it's like we didn't even add anything to this problem. That's kind of what we're doing here. We're manipulating this problem, kind of molding it to make it look different. Now, I can jump to just this parenthesis, and I can factor. So, what times what gives me x squared? X times x. What times what gives me 9? 3 and 3. Do these two things add together to give me 6? Yes. All right. We just factored. Now, the reason why we do this is so we get the parenthesis that's the same for both of these, because I want to rewrite this one more time and say x plus 3. Since there's two of the same, I just put an exponent of 2 up there. Now, let's bring everything else down. We're going to get -14 over here, and then that y is all the way in front. So now we can see my k value is -14. I've got my parentheses with my exponent. I have an x. My h value is going to be -3. Yes, -3, and I'll show you why in a second. My a, there's no number in front of parentheses. It's just going to be a 1. So why is it going to be a -3 when I say +3 here? Well, that negative in that parenthesis kind of messes things up here. So really, if I have x minus, how can I get a positive answer there? By having another negative to make that turn. So the h value just right here would be just that portion. Okay, so how do we use this to find the actual, and this is vertex form. Now, how do we use this to find anything else? Well, if you wanted to graph this very quickly without having to do much, we can find the movements. We know we're going to have a parabola. This parabola shifts down 14, and it's going to shift backwards 3 spots. Okay, so there's a starting point. Can I find the vertex without having to do all that? Yeah, my vertex in vertex form is going to be found by finding, let's see, what is that? H comma K. My H value, now remember I've got that negative up here, so down here it's going to be the opposite, like when I rewrote that and I said x minus -3, my H value is -3, comma, my K in this case is -14, and there's your vertex. So we know we're going to go down 14, we know we're going to go backwards 3, here we're going backwards 3, we're going down 14. It tells us the same exact thing. And that is vertex form.